Good morning, ladies and gentlemen. John Belkowitz here, Director of R&D at Intelligent Concrete. It is absolutely freezing out here. We're over at Garden of the Gods. Took a little vacation and just having a great time. I'm doing some research, reading some awesome papers on super-absorbent polymers and their impact to the hydrated cement matrix and concrete composites, and I just wanted to talk about them today. Super-absorbent polymer is recognized as any polymer that can absorb a large amount of water compared to its own actual weight. So when it comes to super-absorbent polymers and concrete, the reason why we use them, specifically like hydrogels, is because we normally go after healing or self-healing concrete. Self-healing being when the concrete does crack somewhere between 0.25 and 0.75 millimeters, it has something within its hydrated cement matrix to induce healing, part of the original composite. And healing is, after it's cracked, something is sprayed onto the surface or pulled onto the surface or injected into the concrete that initiates that healing process. With super-absorbent polymers, those are normally colloidal silica-based hydrogels or some other type of particle that has a catalyst that gets sprayed or pulled on top of the concrete, migrates into the porosity, and then through some type of hydration kinetics or something else, it hardens within those cracks and stops the permeability. So for assuming we're looking at a colloidal silica-based hydrogel, because that's my research, you have a colloidal silica in solution with some type of catalyst that's sprayed on top of or pulled over the concrete that we've already talked about, and it migrates into the cracks through these different mechanisms that we're not going to go into today. What ends up happening is the colloidal silica plus whatever the catalyst is creates a gel in combination not only with themselves but also with the calcium hydroxide in those cracks and pores. And that gel or super-absorbent polymer can do one or two things. Now let's just look at a super-absorbent polymer. We've gotten the mechanics, the kinetics of spraying the stuff on top or pulling it and migrates in, it creates this gel. If it isn't a colloidal silica-based hydrogel or super-absorbent polymer, a gel that is dehydrated will actually create more of a tortuous path for water and impurities to migrate through that porosity of the hydrated cement matrix in the concrete. Now, a fully saturated super-absorbent polymer will actually allow, so the first one will impede ion transport. The second one, because you have a saturated super-absorbent polymer, it'll actually create a highway for ion transport. So it'll actually increase or make it easier for water and impurities to flow through that tortuous concrete matrix. Now, the reason why a colloidal silica hydrogel is so important, or super-absorbent polymer, is that it creates a polymer train that actually has a certain piece of that hardened hydrated cement matrix that is going to create a more tortuous or fractal-like pathway that goes through that hydrated cement matrix, so effectively reducing not only the permeability but the ability for ions to transport through that hydrated cement matrix. And that's why using that colloidal silica as part of that SAP or that hydrogel is so gosh darn important. So I hope you got something out of that. Don't forget, if you got any concrete questions, any concrete concerns, throw them in the comments sections. Don't forget to like and subscribe. Go concrete, beat asphalt.